Hello dear student, welcome to another live session of Cbse. तो पिछले क्लास में हमने क्या सीखा था कि लाइट रिफ्रैक्ट कैसे करता है और द रिफ्रैक्शन प्रॉपर्टी जो है उसे हमने सीखा था। तो आज हम क्या सीखेंगे कि रिफ्रैक्शन किस किस लॉ से होता है, मतलब कि रिफ्रैक्शन का जो दो लॉ है वो आज हम सीखेंगे। ठीक है बच्चों? तो चलो हम क्लास शुरू करते हैं आज के लिए। ठीक है, तो हम क्या सीखेंगे कि रिफ्रैक्शन कैसे होता है और क्यों होता है रिफ्रैक्शन। सो रिफ्रैक्शन इज कॉज्ड बाय द चेंज इन द स्पीड ऑफ लाइट एज इट मूव्स फ्रॉम वन ट्रांसपेरेंट मीडियम टू अनदर। सो ये हमने सीख चुके हैं, ठीक है ना। So, why does refraction happen? Because of change in the media. Change of the media. There are two types of media. One is denser and the other is rarer. तो हम पिछले क्लास में कौन सा वाला मीडियम डेंसर है और कौन सा वाला मीडियम रेयरर है ये सब हमने सीख लिए। तो अब क्या होगा कि रिफ्रैक्शन कैसे होता है ये भी हमने बता दिया कि द वेलोसिटी ऑफ लाइट का जो वेलोसिटी होता है तो वो क्या होगा, जो मीडियम डेंसर है वहां पर जैसे वेलोसिटी होता है रेयरर मीडियम में वैसा वेलोसिटी नहीं होता, क्योंकि पार्टिकल जो है वो कभी बहुत ही पास रहता है। जब वो पार्टिकल बहुत ही पास होता है तो वो क्या मीडियम होता है, डेंसर, जिसका डेंसिटी ज्यादा होता है। और रेयरर में क्या होगा, डेंसिटी कम होगा रेयरर मीडियम में। सो फॉर द डेंसर मीडियम द वेलोसिटी ऑफ लाइट इज लेस देन द वेलोसिटी इन द एट द रेयरर मीडियम। सो फॉर दैट द लाइट bends toward the normal or bends away from the normal. So अगर ये डेंसर से रेयरर तक जाएगी तो क्या होगा, लाइट बेंड हो जाएगी नॉर्मल से दूर। ये सब हमने सीख लिया और ये भी देखा था कि एंगल ऑफ इंसिडेंस जो है, जो आई होता है, और जो एंगल ऑफ रिफ्रैक्शन है, जब डेंसर से रेयरर मीडियम पर आते हैं तो क्या होगा, वो आई इज लेस देन एंगल आर। क्या होगा, रिफ्रैक्शन का एंगल वो क्या होगा, बड़ी होगी किससे, वो एंगल ऑफ इंसिडेंस से। ये हमने सीख लिए। तो अब हम क्या सीखेंगे कि लॉ क्या है इसका। जो दो लॉ है, हमने रिफ्लेक्शन के लिए भी दो लॉ सीखे थे, फिर ऐसे ही हमें दो लॉ सीखना पड़ेगा इसके लिए, ये रिफ्रैक्शन के लिए। पहले बता देती हूँ कि आज तुम्हारा साइंस क्लास है, ऐसे ही अगले दिन के लिए जियोग्राफी क्लास होने वाला है। ओके, ठीक है। सुनाओ, चलो एक स्पेशल केस भी हमें जानना होगा। तो क्या है वो, इफ अ लाइट रे स्ट्राइक्स द interface normally at 90 degree, it will pass through without any bending or change in direction. So अगर एक लाइट स्ट्राइक करेगा इंटरफेस को, कैसे, नॉर्मली, दैट मींस at the angle of 90 degrees it will pass through without any bending or change in direction. So this is the special case. This is also special case for the reflection phenomena of light also. We know that, right? So now the two laws of refraction, law of coplanarity. So coplanarity के लिए लॉ क्या है, ये same as reflection. This law is same as the law of reflection. The incident ray, the refracted ray. There is only the difference in the term of reflected and refracted. And the normal at the point where they meet all exist on the same flat plane. That means the incident ray. This is the incident ray. This is the refracted ray. This is the refracted ray. And the normal at the point where they meet all exist on the same flat plane. So these all rays are in the same plane. So this is the law of coplanarity. Now the important law, that is Snell's law. Okay. So for a specific color of light. So this is the key word or key term for this law. Specific color of light. So there is 7 colors in white light. Okay, so what are those colors What are those colors? At the very first, violet, Vibgeo. So at the very first, the light is violet, then indigo, then blue, then green, then yellow, then orange, then red. So for a specific color of light and a specific pair of media, the ratio of the sine of the angle of incidence. So sine of the angle of incidence, that means sine I, and the incidence to the sine of angle of refraction, that is angle R, sine R is equal to constant. This constant is known as the refractive index of the medium. So the constant is known as the refractive index of the medium. Okay, right? So sine I by sine R is equal to mu, and this mu is the refractive index. Refractive index. So there are 2 types of refractive index. One is apparent. Okay. One is apparent. So before that refractive index term, we have to study the 2 laws. So the Snell's law is very important for us. We all know that sine 0 degree to 90 degree lies from 0 to 1. So sine 0 का मतलब क्या है? Sine 0 degree होता है 0, sine 90 degree होता है 1. Okay? This is the part of the trigonometry, right? So now, this is the 2 laws of refraction. Now, for the refraction through a rectangular glass slab. For rectangular glass slab, here refraction occurs when light travels from one transparent medium to another, causing a change in the speed and the direction. So for that, there is air in the medium, and it is the medium of glass. So glass medium and air medium, and there is another medium, air. So for these 2 media, there occur refraction. Now we have to study the angle of deviation, or deviation happens in this state or not. This is the question. Okay. So पहले क्या होगा, एयर से ग्लास तक जब लाइट रे इंसिडेंट होगा तब क्या होगा, ये है नॉर्मल, एन डैश है नॉर्मल. सो ये आई है, आई एंगल क्या होगा, एंगल ऑफ इंसिडेंस. ओके, सो वी हैव टू suppose we assume that is I1. So I1 is the angle of reflection, angle of incidence. Okay, this is angle of incidence. So जब क्या होगा, एयर से ग्लास तक आएगा तो क्या, रेयर से डेंसर मीडिया तक लाइट क्या करेगा, ट्रैवल करेगा। तो क्या होगा यहाँ पर देखो, जब I1 है एंगल ऑफ इंसिडेंस, सो ये क्या होगा, नॉर्मल की तरफ, टूवर्ड्स द नॉर्मल। क्यों, यहाँ पर लाइट का जो वेलोसिटी होगा वो क्या होगा, कम होगा। सो क्या होगा, यहाँ पर हम देखते हैं कि ये है एंगल ऑफ रिफ्रैक्शन R1। सो जब यहाँ पर नॉर्मल तो सेम है, तो क्या होगा, यहाँ पर जो एंगल करेगा ये भी होगा R1, क्योंकि ये है कैसा एंगल, हमें पता है। सो वहां भी होगा R1 एंड यहाँ भी होगा क्या, R1। एंड अब क्या होगा, डेंसर से फिर रेयरर मीडियम के लिए ये क्या होगा, रवाना होगी। तो क्या होगा, अब देखो ये टूवर्ड्स नहीं, क्या होगा, अवे फ्रॉम द नॉर्मल, मतलब नॉर्मल से दूर चला जाएगा ये लाइट रे। सो ये होगा एंगल ऑफ रिफ्रैक्शन R2 और I2। सो क्या होगा, देखो इनके लिए यहाँ पर होगा sin I1 बाई sin R1 μ1, एंड यहाँ पर क्या होगा, sin I2 sin R1 बाई sin I2 μ2। सो यहाँ पर हम μ1 μ2 नहीं, क्या यहाँ पर हम एज्यूम करेंगे कि यहाँ पर होगा μA to G, मतलब क्या है, ग्लास कहाँ से, एयर से ग्लास के लिए जाने वाला रे, और ये होगा G to A। ठीक है, सो हम सीखेंगे कि रिफ्रैक्टिव इंडेक्स जो है वो क्या होगा, A म्यू G का मतलब होगा म्यू G बाई म्यू A, एंड G म्यू A होगा म्यू A बाई म्यू G। सो अब क्या होगा, ये इसका बिल्कुल ऑपोजिट होगा। सो हम लिख सकते हैं कि रेसिप्रोकल A म्यू G इज इक्वल टू 1 बाई G म्यू A, बिल्कुल रेसिप्रोकल होगा। तो यहाँ पर हम अगर इन दोनों को मल्टीप्लाई करें तो यहाँ क्या मिलेगा हमको, sin I1 बाई sin R1 इंटू sin R1 बाई sin I2 is equal to A mu G A mu G into G mu A। ठीक है, तो sin R1 सेम होने के लिए इसे हम कैंसिल आउट कर सकते हैं। सो अब होगा sin I1 बाई sin I2 एंड we know that A mu G into G mu A is reciprocal of A mu G. So this also cancel out with each other. So sin I1 by sin I2, here we got that sin I1 by sin I2 is equal to 1. So that means sin I1 or sin I2 is the same. So जो एंगल ऑफ इंसिडेंस है और एंगल ऑफ रिफ्रैक्शन है वो होगी सेम। सो सेम होने के लिए क्या होगा, यहाँ पर लाइट का कोई डेविएशन नहीं होगा, वो जो रे है उसका कोई डेविएशन नहीं होगा। सो रेक्टेंगुलर स्लैब में अगर रिफ्रैक्शन हो भी जाए तो वहां पर क्या होगा, कोई डेविएशन नहीं होगा, देयर इज ओनली लैटरल इन्वर्शन। ओके, सो थोड़ा सा डिस्प्लेसमेंट होगा लाइट रे की, वो भी लाइट रे पैरेलल होगा एक दूसरे से। ठीक है, यही है हमारा रिफ्रैक्शन थ्रू अ रेक्टेंगुलर ग्लास स्लैब। ओके, डू यू हैव एनी डाउट? Okay, right? So changing direction, light rays change direction at the boundary surface separating two different media such as air and glass. At the very first we notice that now bending towards the normal, when light enters from a rarer medium to a denser medium, it bends towards the normal, bending away from the normal. When light exits from a denser medium to a rarer medium, it bends away from the normal. So there is no deviation of light ray because the angle of incidence and angle of refraction are same, so that there is no deviation of light. Okay, just only the displacement, lateral displacement. Okay, Now, the term refractive index. Okay, we can symbolize it with mu or n. So, that's two are correct. So, if you have any doubt to take it n or as mu, okay, both are correct. So, the constants mentioned in Snell's law. So, which constant? Sin I by sin r. Sine of incidence angle and sine of refractive angle. So the constant mentioned in Snell's law is known as the refractive index. It represents how much the speed and direction of light changes when entering a new medium. So speed of light and refraction. So light travels at different speeds depending on the material, and it is fastest in a vacuum. So the speed of light in vacuum. Anyone from the comment section? Do you know the speed of light in a vacuum? So what is the speed of light in vacuum? Anyone from the comment section? Anyone? We all know it, right? C. It is symbolizes by C. So, what is the value? So, what is the value of light in a vacuum? Anyone? So that is 3 into 10 to the power 8 meter per second. Okay. So it is the fastest value of speed. So its speed is slightly lower in air and decreases significantly in materials like glass or water, because in vacuum there is no presence of any particle. So for the particle presence, the speed decreases. Okay, because of the collision of the ray with the particles of the medium. Okay, so now for denser medium, we know that density is higher, and for rarer medium, density is lower. Okay. So यहाँ तक कोई डाउट है तुम लोगों को? We have to study about the refractive index. Okay. Now, the refractive index, there are two types of refractive index. One is absolute and the other is apparent. So we have to study about the apparent. Okay. So what is absolute refractive index? The absolute refractive index is C by V, denoted by the equation C by V. So the speed of the ratio of the speed of light in vacuum and the speed of light in any medium. So this is the medium's absolute refractive index. So for one medium, the absolute refractive index of a medium is C by V. So this is the refractive index, and C is the speed of light in vacuum V is the speed of light at the specific medium. So for this medium, one specific medium, there is one absolute refractive index. This is C by V. And what is apparent refractive index? So अगर तुम्हें 90 मिले एग्जाम में और तुम्हारी एक दोस्त को मिले 98, so क्या होगा? 98 तुमसे, वो दोस्त 8 मार्क्स ज्यादा मिले उसको, ठीक है, तो उसके मुकाबले तुम्हारा स्कोर 9 होगा। वैसे ही एपरेंट मीडियम होता है, एपरेंट रिफ्रैक्टिव इंडेक्स होता है कि वन मीडियम से दूसरे मीडियम को मीडियम की जो रिफ्रैक्टिव इंडेक्स होगा वो कितनी ज्यादा और कितनी कम होगी, वो होगी एपरेंट रिफ्रैक्टिव इंडेक्स। दैट मींस 1 n2 or n1 2 both are same. So what is the refractive index? So the refractive index of n2, that means the second medium, the refractive index of the second medium to the refractive index of the first medium is known as the refractive index of second medium from the first medium. Okay, for those two media, this is the refractive index. And for n21, okay, n21, so that means n1 by n2. So we can easily write 1 by n2 by n1. So n2 by n1 represents the n12. So we can easily write here n12. So this is the reciprocal of the refractive index of n12, and n21 is the reciprocal of refractive index n12. So for those two media, one apparent refractive index is reciprocal for the other one. Okay. So do you have any doubt? ठीक है? तो चलो, so its speed is slightly lower in air and decreases significantly in material like glass or water, because material का जो डेंसिटी होता है वो बहुत ज्यादा होता है, इसलिए वहां पर क्या होगा, स्पीड स्लो होगा। ठीक है, यहाँ तक समझ में आ गया सबको? तो चलो ऑप्टिकल डेंसिटी और मास डेंसिटी के बारे में थोड़ा सा जान लेते हैं। तो क्या है वो? इट इज क्रूशियल टू डिस्टिंग्विश between optical density and mass density, as they are not the same term or thing. Okay, optical density relates to the ability of a medium to refract, that means to bend the incidence light. Okay, and mass density relates to the mass per unit volume of a substance. Okay, so optical density is the ability of a medium to refract light, and mass density वो क्या है जो relate करता है कि mass per unit volume, that is the density of a substance. Okay, this is the normal density term. So kerosene has a higher refractive index than water, making it optically denser than water, even though its mass density is lower. So kerosene floats on water because the mass density is lower, but the optical density is higher for kerosene. So kerosene has the higher refractive index than the water. Okay, so we have to distinguish the both terms. One is optical density and the other is mass density. Okay, so that's all. Now for the next part. Okay, lens. We have to study about lens. तो lens क्या है? Lens हम तो देख चुके हैं कि कन्वेक्स लेंस भी देख चुके और देखा कि कनकेव लेंस भी देख लिए। तो वो जो ग्लास हम यूज करते हैं कि ग्लासेस है, वो तो लेंस ही होगा, ठीक है ना? सो वन फॉर मायोपिया एंड वन फॉर हाइपरमेट्रोपिया वी यूज लेंस. ओके, दैट इज स्पेक्टेकल्स. For myopia, we use concave lens, and for hypermetropia, we use convex lens. Okay. ये सब हम बाद में जानेंगे, ठीक है। तो पहले लेंस क्या होता है ये जानना है हमें। A lens is defined as a transparent medium enclosed by two surfaces, and those two surfaces where at least one of these surfaces is spherical. So this is the double convex lens. This is the double concave lens. This is concave convex lens. And this is convex concave lens. So there is 6 types of lens. Okay. So plano convex lens, plano concave lens. Okay. So we have to study about two lenses. One is convex lens, that is double convex lens, and one is concave lens. So this is the topic to study. Okay. Now types of lenses. So पहले हमें क्या जानना है कि कन्वेक्स लेंस के बारे में। तो हमने जब मिरर के बारे में पढ़े थे तो क्या सीखा वहां पर कि कनकेव मिरर जो है वो कैसा होता है कि कनकेव मिरर जो है वो कन्वर्जिंग टाइप का होता था। तो अब क्या देखेंगे हम कि कनकेव लेंस बिल्कुल कन्वर्जिंग नहीं है, ये उसका ऑपोजिट है। तो हमें क्या जानना है कि कनकेव मिरर वो होता है कन्वर्जिंग, बट कनकेव लेंस कन्वर्जिंग नहीं होता। तो क्या होगा, कन्वेक्स लेंस होता है कि कन्वर्जिंग लेंस। वी हैव टू रिमेम्बर इट, राइट। कन्वेक्स लेंस होता है कन्वर्जिंग लेंस। ओके, वी यूज दिस एज मैग्नीफाइंग ग्लास। तो हम मैग्नीफाइंग ग्लास तो देख ही चुके होंगे, ठीक है। So a double convex lens has two spherical surfaces that bulge outward. Okay, we know that physically it is thicker at the center. So from the diagram we can see it that it is thicker from the center and thinner at the edges. When parallel light rays pass through it, they are bent inward to make a single point. Because of its behavior, it is commonly referred to as a converging lens. And concave lens क्या होगा, diverging lens होगा। क्यों diverging होगा कि a double concave lens is bounded by two surfaces that curve inward. It is thinner in the middle. Okay, it's thinner in the middle, we know that, and thicker at the edges. So this lens causes parallel light rays to spread apart. So कैसे वो पैरेलल रे ऑफ लाइट जब इंसिडेंट होने वाला है यहाँ पर, तो क्या होगा, इसको ये स्प्रेड कर देता है। सो इसलिए इसको हम क्या बोलते हैं, डाइवर्जिंग लेंस। ओके, सो फॉर द मिरर concave is converging mirror, and for lens the convex lens is the converging lens. Okay, so for diverging and converging, the both are different for and opposite for the mirror and the lens. Okay, so it diverges, the light ray diverge after passing through it, which is why it is known as diverging lens. Okay, got it? Now optical center and aperture, the central point of a lens is denoted by letter O. So for a convex mirror, okay, for a convex lens, this is the point O, this is the central point, optical center, and what is the aperture, known as the optical center. And a unique property of this point is that any ray of light passing through it does so without any deviation or bending. So वो जो light optical center से pass होने वाला है, वो लाइट किसी तरफ भी बेंड नहीं होता। वो क्या होगा, वो लाइट जहां से आते ही उस रास्ते से ही वापस उस रास्ते से ही क्या चला जाता है। So it's do not deviate. Okay, it is do not deviate, a unique property of this point. This is the unique property. Okay, for any lens that is convex, that is concave, for any kind of lens, this is the unique point or unique property of the optical center for them. Okay, now So the effective diameter of the circular boundary of a spherical lens is called its aperture. So if we take this point as M or M dash, this is the M dash distance is known as the aperture. We all heard about aperture of a camera, and camera is also a lens, that is convex lens. Okay, we all know that, right? So never look directly at the sun. Why? Why we do not look directly at the sun, especially through a lens? Why does it cause permanent eye damage? Because if held steady, the paper will begin to smoke. This is the experiment. We all did this experiment. Okay, right? So this happens because the convex lens converges the parallel ray of sunlight into a single concentrated point. This bright spot is actually a real image of, this is not the shadow, this is image, this is real image of the sun, and the intense heat generated by the concentrated light caused the paper to burn. For that, the retina must be affected for this converging rays. Okay, so never look directly at the sun, especially through a lens, right? ओके ओके तुम्हें कहां पर डाउट है कि देखो ये जो कन्वेक्स लेंस है वहां पर क्या होगा, लाइट जो पैरेलल रेज इंसिडेंट होगा वो क्या होगा, एक पॉइंट पर ये जाके इंटरसेक्ट करेगा. सो इन दिस पॉइंट ऑल द लाइट, यहाँ पर जो भी पैरेलल रे आएगा वो सब लाइट कहां पर, एक ही पॉइंट में आकर रुकेगा. सो वो पॉइंट है कन्वर्जिंग पॉइंट जहां पर सब लाइट एक तरफ आके मिलेगा. सो दिस इज द इमेज ऑफ, दिस इज अ रियल इमेज, दिस इज द इमेज ऑफ सन. ओके, सो द ब्राइट स्पॉट इज एक्चुअली अ रियल इमेज ऑफ द सन. तो वो क्या होगा, वो सन का रियल इमेज होगा. सो इसलिए क्या होगा, इसका इंटेंस जो हीट होगा वो क्या करेगा, रेटिना को जला डालेगा. समझ में आ गया क्या? ओके, ठीक है. तो पहले हमें ये जानना है कि कन्वर्जिंग रे क्या होता है. देखो कन्वेक्स मिरर में क्या होता है, पैरेलल रेज are converged. So do you know about converging light ray का convergence का मतलब तुम्हें पता है प्रिंस? पता है तुम्हें क्या कि converging क्या होता है, एक ही पॉइंट पर जो है फोकस, प्रिंसिपल फोकस पे वो सब रे आके मिलने वाला है. So this is the point of intersection. So all the ray converge at this point. So जो पैरेलल से आने वाला रे था तो इसका हीट क्या होता, ये तो स्प्रेड हो जा रहा था. सो अब क्या होगा, ये कन्वर्ज हो रहा है. सो सब हीट एक, ओके प्रिंस, सो यू आर फ्रॉम बांग्लादेश. ओके, बहुत बढ़िया. सो क्या होगा, यहाँ पर लाइट जो है कन्वर्ज होगा, इसलिए जो सन का इमेज होगा वो क्या होगा, वहां पर बहुत ही हीट जेनरेट होगा. एंड Okay, so now ठीक है, चलो तो कंटिन्यू तो करना ही होगा। चलो, लेकिन अब क्या है कन्वेक्स लेंस? The ray refract and converge at a specific point on the principal axis. This point is called principal focus of the convex lens. जैसे कि अभी जो डायग्राम ड्रॉ किया गया था वहां पर मैंने बताया कि जो parallel rays is bends towards and meets at the point which is known as the principal focus. Okay, and the principal focus is situated at the principal axis. This point is known as principal focus of the convex lens. And for concave lens, we studied that the concave lens diverge the rays. So when the rays are diverging, so we have to take the rays backward and the point where it meets, that means the apparent focus point. This is the principal focus point for concave lens. Okay, so since light can pass through a lens from either side, every lens has two principal focal lengths. Okay, and what is focal length? The focus point, the principal focus point, the distance between the distance between the optical center and the principal focus point is known as, the wave distance is known as the focal length. So focal length, we can measure the approximate focal length of a convex lens by measuring the distance between the lens and the sharp image of a distant object like the sun formed on a screen. So that's how we have to find or measure the distance of the focal length. Okay, now rules for drawing ray diagram. So this is very important point and this is very important topic also. So how to draw the ray diagram? So to determine where an image will form, we typically track at least two specific types of light rays as they pass through a lens. So it is just like to draw the diagram of image of a mirror. So that's how it will be drawn. Parallel rays. So the rays are traveling parallel to the principal axis will, after passing through a convex lens, converge and pass through the principal focus. We all know that. This is converging lens and the parallel rays meets one point and that point is the principal focus of on the opposite side. In a concave lens or for a concave lens, the principal focus in the inward side. Okay, because the rays are diverged. Okay, now so the ray appears diverged from the principal focus located on the same side as the incoming light. Now rays through focus. So we know that a ray, so this is the vice versa of the first law. That is, a ray that passes through the principal focus for a convex lens or is directed towards it for a convex lens. Concave lens will emerge from the lens traveling parallel to the principal axis. So rays through the optical, now these two are vice versa of each other. Okay, now the second law is rays through the optical center, and we read the unique property of the optical center, and that is any light ray passing directly through the optical center of either convex or concave lens will continue in a straight line without any bending or deviation. Okay, so this is the 2 points. So we have to draw a ray diagram. Okay, so for that, for magnifying glass, so M dash is the convex lens. Okay, right? And AF, this is the principal focus point. Now, and this is 2F distance. That means this is the distance from the focus. This is the 2F distance. Okay, right? Now, मैग्नीफाइंग ग्लास के लिए हमें क्या, जो ऑब्जेक्ट होने वाला है उसको हम जहां पर प्लेस करेंगे उसके मुताबिक वो इमेज फॉर्म करेगा. सो फॉर द मैग्नीफाइंग ग्लास वी हैव टू प्लेस द ऑब्जेक्ट एट बिटवीन द ऑप्टिकल सेंटर एंड द प्रिंसिपल फोकस. ओके, सो वी हैव टू ड्रॉ द टू लाइट डायग्राम. Okay, we use plane mirror, right? We use plane mirror, and for this is there happening lateral inversion, and that is B. We get same size of the object. The image is as same as the object, but there occur lateral inversion. And the distance of the image is equal to the distance of the object from the mirror. For this is a plane mirror. This is the plane mirror. Okay, got it? Now, for the parallel ray, it bends through the principal focus F, and we know that for both sides there is two foci points. Now, one go through the principal focus and other does not bend because it go through from the optical center. So now we have to draw it backward. So here we got the image. So this is PQ and this is P dash Q dash. We got the image at the same side of the incoming ray, at the same side of the object. Okay, and this is magnified. This is magnified rays or enlarged object. Enlarged object. Enlarged image of the object. For this property, we use convex lens as for magnification purpose. For magnification purpose. Right? Got it? Do you have any doubts, students? So, okay, that's how we have to draw the ray diagram of the convex lens. So, sign conversion for spherical lenses. It is important also. When measuring distance in lenses, we use a system similar to spherical mirror, known as the Cartesian sign conversion. So, measurement, the origin. All distances are measured starting from the optical center. So, that is the optical center. And from there, of the lens, focal length, by convention, the focal length of a convex lens is always positive. Convex lens के लिए वो always positive ही होने वाला है, और the focal length of the concave lens is always negative. So it is vital to apply the correct positive or negative signs to the object distance, image distance, focal length, and the height of the object and the image. Okay. So now the lens formula. So what is the lens formula? It is mathematical relationship between the distance of the object from the lens, the distance of the formed image, and the focal length. So what is the formula? So we don't need to study the derivation of the formula. Just we need to know the formula, which is 1 by v minus 1 by u is equal to 1 by f. So what is v and what is u? V is the image distance of the image from the center of optical center, and u is the distance of the object from the optical centers, and f is the focal length. So this is the lens maker formula. Now the power of lens. So we all know about the term power of a lens. Okay. So the power of lens represents its mathematical ability to bend light either by converging when it is convex lens and for diverging when it is concave. So relationship with the focal length, which is the relation is P is equal to 1 by f. That is focal length की रेसिप्रोकल को ही हम पावर इसे पावर कहा जाता है कि P is equal to 1 by f. And what is the unit? The unit is diopter. Okay, the unit is diopter. So it is symbolized by the letter D. So this is the unit. SI unit of power of a lens is diopter. So indicates when positive power, it indicates a convex lens, and negative power indicates a concave lens. So we know that for spectacles the power is positive or negative, minus 0.5 the power of the lens, plus 0.5. So when it indicates concave lens, this is negative, and for positive power it indicates a convex lens. And diopter, we know that 1 by AF is P. So when AF is in the meter, so the SI unit of focal length is meter. So meter inverse is known as the diopter. Okay. So this is the unit of the power of a lens. So that's all for today. So this is the chapter light and lens. There is two phenomena. One is reflection and other is refraction. So that's all for today. Yes, F is equal to focal length, the distance of principal focus from the optical center. So that's all for today. So thank you for watching, and please subscribe our YouTube channel Eduins Cbse to get more live classes and videos. R is the center of curvature. R is the center of curvature. Okay, got it? What is R? R is the center of curvature. Okay, R is the center of curvature.